Good evening, all. We are super excited to have you all here. Today we have Chitra, Dima, and Sushrut from JFrog team. Chitra will today. Chitra, over to you.
Hi everyone, we are excited to be here today. So my name is Chitra. I'm on the JFrog. We are excited to be part of your Meetup community tonight. We have two great talks from some of our JFrog speakers for today. First, I will share a little bit about JFrog. We are the DevOps software company known best for Artifactory, which is considered by many as the gold standard for managing your artifacts and dependencies. In fact, JFrog has a free cloud version of Artifactory for the Go community to use it seamlessly with the Go package manager. Also, if you are working for Docker, as I know many of you are, JFrog Cloud subscription is capable of functioning as a pull-through cache for your Docker hub. And with our free version, you will be exempt from the Docker rate limits on pulls from free and anonymous accounts. Also, another bonus for tonight, we want to give you a chance to win JFrog Go t-shirts. It will be sent to you within 3 working days, 3 business days. I will drop the link for the raffle soon in the chat box as well. I would like to share the screen. Just give me a moment, please. I hope you can see my screen.
Yes, Chitra, it's visible.
Yes. So this is a bonus for tonight, what I was talking about. So we want to give you a chance to win a free Go T-shirt, which will be sent to you in 3 business days. So you can enter the raffle by scanning the QR code or the Bitly link, which I will share in the chat as well. There will be a place for you to put your address and also your T-shirt size on the form. So thank you, Chamod, for this opportunity. We have two wonderful speakers from JFrog for today. So all over to you. Thank you.
I can begin the presentation.
Yeah, sure.
All right, let's see. Tell me please if you see my screen. Can you see it?
Yeah, it's visible now.
Okay, great. Okay, hello everyone. I'm going to talk today about the errgroup package. I'll present an overview of this package. So just a couple of words about me. I'm a software engineer in JFrog Security Team, the X-Ray product. I've been working in JFrog for the last 5 years. All those years, I've been working as a Go developer. So let's jump right into it. Before presenting the package, I'll present the need. So first of all, I'm sure that all or most of you are familiar with the wait group. Wait group is a mechanism for synchronization of Go routines. The way it works is we define this parameter, wait group. Then when we run our Go routines, before running the Go routine, we add increment the work group. And after the Go routine completes running, we make sure to call done on the work group. And in the end, like outside of calling the Go routine, we call the method wait. What this does is that wait will actually block here on this line until all Go routines completed. And then it can continue. So this way we can ensure that when we exit wait, we know that all the workers are done with their job. So this is a very common pattern in Go. But what is missing? There is something very common that we do in Go, but not clear how to implement it. Not obvious. What happens if we have some error when running, when our Go routine of the worker fails for some reason, how do we deal with it? Maybe if the Go routine fails, we want to fail the whole operation, right? To say that if some worker failed, this operation didn't succeed. So the regular way to implement it would be to pass to the worker some channel, some error channel, and then we should listen on it from outside and treat it. But actually, there is a very nice wrapper. This wrapper is called errgroup. It is not part of the Go standard library. You should import it explicitly as a Go module, but it is official. It comes from Google, and it provides this functionality where it is a wrapper around the scene group, and the implementation is quite symmetrical. So instead of defining the sync wait group, we initialize an errgroup object. Then instead of explicitly running it like that inside the Go routine, Go with the function, we're calling the Go method on the errgroup. No need to increment and no need to decrement anything. It happens automatically. And in the end, after we call g.wait, it will return the error to us. If some error happened here, then the error will be returned. So the ggo, the signature is that it receives a function that doesn't get any parameters and returns an error. So if any of the workers here has an error, then what happens is that the errgroup will also return an error. And this way we'll know that something happened here. Something bad happened. By the way, this slide contains a bug. Is anyone here? Can anyone tell me what this bug is? Is it allowed for the listeners to participate, by the way, or they're muted? Can you hear me?
Yeah, I think participant can comment in the chat so we
Let's
can
see what
give
you
answers.
guys comment. I'm just curious if you find the bug in this slide. It's a super common bug. Okay, I'll just share it with you. If no one sees it, or maybe people are shy or still didn't see it. So I'm sorry. It's kind of embarrassing, this bug, but it's also a good opportunity to talk about it. So actually what happens here is that this method starts asynchronously. And if it starts asynchronously, then this variable is actually a reference. So this I, it will actually be the same, if I'm not mistaken. Please, better to check it. But as I see it, instead of using it as is, what we should have done is that we should put another variable called j, say j equals I, because this I, it is actually saved as reference. And this way of definition of the function, it is a closure.
Dima, I think you need to reshare your screen.
Oh, I'm so sorry. I need to share my screen. Sorry, guys. Just a second.
Yeah, that's okay.
Let me find this. Share my screen. Right. Right. So I'll repeat. So
Now we can
in
see
this
it.
example, yeah. So what happens in this example is that this definition inline definition is actually a closure. When we define a closure that runs asynchronously in the Go routine, it means that it actually captures this variable, the I variable. It captures it. And then actually it will be a reference to this variable. Even when the variable changes its value, the many Go routines, they will actually have the same reference. This is another common Go pitfall. So in order for this not to happen, we probably should put another local variable inside the loop, call it j, and then no reference will be called because j will always be like copied. It will not be referenced anymore. But this is another topic, so I'm sorry for this bug. Okay, so this is very similar to the sync wait, but has the additional benefit of wrapping returning the error to us. So this is nice, but I would also like to extend this example and maybe say that if we are running and we introduce an error, maybe we would like to cancel the whole operation. So maybe we have like 10 workers running and we want to say, if some of them failed, let's signal to everyone to stop the processing. And maybe there is even a more complex scenario when we have some producer or several producers and several consumers. And if in any of them some error happened, then we want to stop everything. So I actually did implement this without any error group, like by myself. And it took me a while to get it right. It's not completely obvious how to get it right. And I was very proud of myself. But then I told some colleague and he said, did you try the errgroup package? And then I re-implemented it with the errgroup package and it looks much less impressive now, the implementation, much simpler. And actually, from one side, I was a little bit disappointed, but from the other side, of course, it's much better because anyone can do it and there is no need to get into any intricacy to get it right anymore. So I will be glad to share with you this example. Okay, so before we go into it, the errgroup package it has very small interface. It has only 3 methods: with context, go, and wait. The methods go and wait, we already seen these methods. It's called the go routine and it waits on the go routines to complete. And the last functionality that I'm going to present to you now is exactly the functionality that supports the canceling. And it happens with context. So we're going to see it right now. So here is the example. Let's take the example of a pipeline. How does it work? We have some go routine that it generates the tasks, task generator. We have workers that are processing the tasks, similarly to what we saw before. And the requirements are that task generates tasks, sends the tasks to the workers, and after it completes to generate all tasks, there is a limited number of tasks. After it completes, it signals to all the other workers that it finished. It finished after all available tasks have been generated already. In case some error happens, either in the task generator or in one of the workers, we expect all the processing to stop, to complete, both generating and processing. And our main process, it waits for all the subroutines to complete for the generator from the workers, and it returns an error in case some of the subroutines has failed. So how can it be implemented with errgroup? We're using the with context functionality. If you remember before, our previous initialization was like that, just a new method. But in order to support the cancellation, we initialize it this way, errgroup with context. We give some context. Here I didn't have any previous context, so I used context background. But if I have, I could pass the other context. So like that I initialized. Now I have the context that can be canceled, that I can listen on. We prepare some channel on which we will be sending the tasks. And we have here one go routine for the task generator. And we have several go routines for the workers. Here this call is totally fine, no problem, because I guess because it is passing the parameter, it's not closure anymore. this value is being copied and not passed as reference. So here it is fine. We're calling the go routine for each of the workers, and in the end of the process, we wait. If some error happened either here or here, we will get the error. But how do we deal with the cancellation? How do we deal with if here we fail or here we fail, then everything stops? So the way to approach that, I'll share with you both the code of the generator and the code of the workers. And this will be the end of our example. So this is the code of the sender, of the generator that generates the tasks. This is just a pseudo code, right? It's not a whole example, but suppose that from somewhere it gets a list of updates, and for every update it generates a task. So it runs on this collection of updates, calls the method generate task. It can potentially fail, let's assume. And if it failed, it returns an error. If everything is okay, it tries to send the task on the channel. This is the same channel that the worker will be receiving from. The task generator sends the tasks on the channel, and the worker reads from these tasks. Now, a common Go pattern says that the generator, after it completes sending all the tasks on this channel, it closes the channel. Closing the channel signals this operation in the first line, that because we are calling defer, we ensure that it happens no matter what. This code will be called eventually after we complete the iteration. It ensures that it sends the signal to our workers that they should stop processing. How it works, I'll be back to the generator slide in a minute. I just wanted to show you how it works in the worker side. So in the worker side, we'll we receive tasks from the channel using this iteration. We're raging over the channel, and then automatically Go knows to break off this loop when the channel is closed. So as long as this channel has not been closed yet, it will block, waiting for the next task to arrive, takes it, does something with it, tries to receive another task. Once the channel has been closed, the Go breaks from this loop. So this way we can signal, the generator signals to the workers that it completed generating the task. Until now, not using functionality of errgroup at all. Where errgroup comes into play, here, in this context, done. So when the context has been cancelled, the done channel will be closed. Context has a done channel, and we receive from it. So here we have this block that is called select. In this block, it's randomly chosen, like the first channel that we can receive from, it will be chosen. So either there is some worker that is ready to receive a new task that is listening on the channel, or someone signaled to us that all processing has been stopped, that the context has been cancelled. This is done by listening to the done. So this way, when context done will be called, errgroup calls it automatically when some error happened, either when we finished waiting or when some error happened. So if some of the worker fails, the done channel will be closed, and then the sender will know to close it, to break from the loop, because it will receive on the done that everything was completed. While it doesn't happen, we keep trying to send. So we have 2 ways to finish this. Either we complete iterating over all the updates, and then we exit and we close the task channel, or some error happens, and then we exit here on context done. This is the generator, the sender side. What happens on the receiver side? On the receiver side, we have the same concept of this select block and 2 conditions. We range over our task channel, as I explained before. and either we just receive a task, and then either we are processing it, or something happened, the context was cancelled, and then we break off, we exit. So in the regular flow, we'll just never enter the done, never enter this done condition. We will always go to default process task continue, default process task continue. But if some error happens, we will exit on the done stage. So this way we will be able to satisfy all the conditions. We have generator, we have processing workers. If some error happens, then it will be returned by our main process. We will know about that. And moreover, when error happens, we will know immediately to exit, both in the generator and in the workers. And that's all. That was my presentation.
Great. If you have questions, please ask them in the chat.
Have ever someone lost me? There was some period when I was not sharing the screen.
Yeah.
Something was not clear.
Situ? He lost the fast test.
Fast
He's
test, I
asking you to, yeah.
never talked about fast test. It was not part of this presentation, and I'm actually very curious about fast test, but it's not NWS.
Okay. So, no questions.
What is NWS?
That means no worries.
Okay.
Okay. So, thanks Dima for informative session. Actually, Dima is a senior software engineer from JFrog Security Team, and he has 5 years experience programming in Go. He is from Israel. So now it's time to move to our next speaker, Sushrut. He's a software engineer also from JFrog. He's working on the partner engineering team, and he's a full stack web developer who is skilled in object oriented language including Golang, Python, and C++ and Java. And he also has a passion for UX and UI design principles. Sushrut, uh, over to you.
Thank you. Good evening, everybody. My name is Sushrut Athavale. I am like he said, a software developer at JFrog. My role in the partner, sorry, give me a second. I need to enable permissions so that my Google Chrome can share my screen. Oh, and Google Chrome will not allow me to share my screen until I restart. So I will be right back.
Meanwhile, till Sushrut is back, I just wanted to reiterate it again. Please go ahead and get an opportunity to win a Go t-shirt. I have dropped the links on the chat box. You can fill the form, and also we have provided a link for the Artifactory free tier, which you can try for free. So please go ahead and register now. Thank you.
Shosrut, you on mute.
Sorry about that, everyone. I am back. I needed to restart my Chrome so that I could share my screen. But yeah, I should be able to share my screen now. Yes, and let's share this. Okay, so talking a little about designing as a developer with some examples in Golang. Just a little bit about me first. My name is Sushrut Athavale, and I'm a software engineer at JFrog. I'm a DevOps developer. And if you want to follow me, there's my Twitter handle right there. So unlike the last talk, which was very technical, my talk is more broad strokes about design and development in general, and how we can become better developers by learning more about the design process. And so my talk is is how we as developers can learn about UI UX and design to improve our products and our value as developers. And I'm going to be talking with some examples in Go today about this idea. So the main thesis of this talk is this line right here, that the disconnect between design and development can often be fatal. I worked at Amazon for a bit a few years ago, and one of our projects at Amazon was a front end project, and I was a developer, and we had designers on our team, and the designers would often tell us to do X thing in Y way. They would say, we want a window here that does this, and I would go and make a window here that does this, and our entire team would do that. Eventually, we as our product kept rolling, we realized that there was things weren't quite working as well as they should have, according to the designer's vision, and what the tools we had as developer, they also weren't working as well. And we realized there's some major disconnect or error happening, where what the developers could build and what the designers could imagine wasn't lining up to each other, and it ended up causing the product to fail in a pretty big way. And we had to really go back and look at it and see what was wrong with it. Um, and that's one of the first places I learned about this idea of, hey, maybe it is useful for a developer to know design principles when working, because then a developer will be able to create a product that a customer would really like. And they'd be able to understand and implement a designer's vision in a way will be that it will really add value to the product. And adding value to the product adds value to yourself as a developer. So the idea behind this is to teach some basics of user experience so that you can add your value to a product and to yourself when developing. So when you can design your own products in a way that a customer will be able to use it. So we'll be going through these 7 facets of user experience. These 7 facets were coined by this man named Peter Morville, who writes some blog posts and books about user design. But these ideas have been around for a while, and are fairly universal. So our first facet I want to talk about is usefulness. This one is fairly self-explanatory. The things you make should be useful, and so this includes and the key caveat for something being useful is that you shouldn't lose sight of your end goal or what you're trying to build. As developers, especially with Go, there's a lot of cool things we can build. Like there's a lot of servers we can build. We can do some awesome things with concurrency, but the things we build aren't always useful to your colleagues, to your customers, to your product managers. And it's important to know where you're spending your time so that you are building useful things. I know that when I first learned Bash, for example, it was my first scripting language, and I would spend time scripting everything I could because I just wanted to learn it, and it was useful to me to do those tasks. But one time I ended up spending 4 hours automating a work task that only takes 5 minutes to do. Um, and it really saved me those 5 minutes, but in the end, the 4 hours of work wasn't a useful work. I have an Eye of the Beholder here. It's a Nintendo game, because usefulness in that sense is in the eye of the beholder. useful, something that is useful to you may not be useful to someone else, and it is important to consider that when you're going to take a large time commitment to do something. Maybe something isn't worth the time to build if it's not going to be useful. And if you can save yourself that time, you're saving your company that time, and you're increasing your value as a developer. The next facet of user design is usability, or usable. Unlike useful, which is a very similar word, useful means that something is something can be used, that something is needed by a customer, whereas usable means a customer is able to operate or able to use that product very easily. So an example would be a taxi service is very useful for a customer to have. People love to ride taxis, rickshaws, anything. Um, but it's not very usable to use taxis when you need it, especially in the US. Like there's it's hard. It used to be really hard to get a taxi in the right spaces, etc. And you don't know the price of a taxi before you went. So Uber, for example, was a very usable app that came out that really disrupted its market on a pure usability basis, um, because and really entrenched itself. And so two other apps that were really usable that operated in an existing market and basically made its first successes on usability were Robinhood and Venmo. Venmo disrupted the banking market. It disrupted peer-to-peer transactions. Peer-to-peer transaction services existed before Venmo. There was PayPal, for example. But by making it into a mobile app and making it very easy to send money from each other, Venmo really entrenched itself in the space. The same thing happened with Robinhood, where Robinhood investing was something that everyone could do before, but Robinhood enabled the masses to do it. It's a consumer investing app, this logo on the left. So it's really important to make things usable. And it can really, making something that already exists usable is very good for making new products as well. By the way, I'm going kind of fast. If you have any questions, please leave it in the chat. I will answer it at the end, or I will stop in the middle to answer it. Um, uh, yes. Okay, findable. So this is the third facet. And we're starting to get into some more exciting facets of user design. When you're making a product, it is really important. It's very, very important that a user can find the things you're building, that they can find how they can figure out how to use your product itself. Like if you have a feature, they should be able to find where that feature is. This is also known as discoverable, by the way, if you're looking at this up online afterwards. A great example of this is a command line interface. You can build some really robust command line interfaces in Go. And command line interfaces have a very simple way of making your commands findable. You just run a help command and it'll list all of the commands you can run at the time in a nice, neat little list with a description for each. But imagine if that help menu wasn't there, then the features you spent a long time on for a command line interface wouldn't be findable. Findability is interesting because it doesn't have to be as explicit as a help interface. One really interesting way to make something findable is to make it is to follow a metaphor or an industry standard. So in this case, I'm a DevOps engineer, so I spend a lot of time building stuff with Kubernetes, and a big part of Kubernetes is a command line interface built in Go called kube controller. The kube controller in Kubernetes have a very specific way of have a very specific language and how they interact with objects within it. So kubectl will always do kubectl the command line controller. Then it will say a verb like create, expose, run, or set, and then it'll have the object it runs at. So kubectl create pod. Um, some other command line interfaces will do it the other way. They'll have the object and then the verb they want on the object, like you were speaking in English. It's noun and then verb. But kubectl does verb and then noun. So then you'll find that most people who are building command line interfaces that deal with Kubernetes, and I did work and I built a command line interface that was built off of Kubernetes. They'll follow the same format as Kubernetes, and they'll do verb and then the object that it's operating on. So when you're building something in Go, for example, and you're working in an established industry, really pay attention to what other people in the industry are doing, especially bigger companies. And if you copy their design and their formatting, you'll find that customers will be saying like, wow, I'm using your product because it's more easy, it's because it's easier to use. And that's something that a designer or a product manager is probably not going to coach you on. It's going to have to be coming from you. And if you can naturally be like, wow, this developer's programs are much easier to find, their customers are reviewing them higher in usability and findability, I really like it, then you can be like, hey, like this is a skill I have, and it's very good. So that's findable. The next facet is credibility. When you're building a product, you want people to trust that your product will work well. If you say you're going to do something, your customers to trust that you are going to do something. Um, credit A lot of these facets are easy to measure, by the way. Like usability is easy to measure, and I'll get the we can talk, that's more of a topic for another day. But credibility is not as measurable as findability, usability, or usefulness. You can get metrics at like clicks, you can look at how often people are using things, etc. And so the first three are easy to measure. Credibility is very hard to measure, and it's very hard to know if you're doing right. So it can be very difficult in that way. And credibility is important, and it's very easy to lose. Facebook, for example, has lost a lot of its credibility in recent years due to these data and privacy issues that they're having in the media. How do you build credibility then? How do you know if you're doing it well? If it's something that is difficult to measure? Well, one easy way to do it is professionalism. When you're presenting information or your product, make sure there's no typos. Like really pay attention to how everything is spelled. Have the presentation be clean and straightforward, and that'll help a lot. Another easy way to build credibility is to, again, follow industry standards. Something is standard in the industry, usually because it has credibility and it feeds off of itself. One example of that is documentation. Documentation used to come in books. It used to come in a downloadable PDF that you could download and read through for your Java docs and stuff like that. And but that is no longer the optimal way for most developers. Most developers, if they saw they had to download a PDF to learn how to use their product, aren't going to download that PDF and going to say, this product doesn't have good documentation. So you shouldn't give a PDF download as your main source of documentation anymore, because it's not a very credible source. There is this Golang framework, not framework, or a library package called Cobra. And it is it's a big set of commands basically that allows you to build CLIs in Golang. It's open source if you look it up online, and you can build some really nice command line interfaces with Cobra. Cobra is really useful, and a lot of people use it because it directly builds off of the paradigms that Go sets. It built its credibility based off of what Go is advertised it as, itself as. So if Cobra basically took the paradigms of Go and did whatever they want with it and didn't follow them at all, then people wouldn't use it. So for example, some of the paradigms of Go is that it's object oriented, it's imperative, and and it's concurrent. And most importantly, Go is easy to use. That's another one of their paradigms, that they want to be easy to use, just like ternary operators. And so Cobra also follows that thing. So you can do concurrent command line interfaces, et cetera, et cetera, et cetera. And it built its credibility off of that. Okay, sorry, just taking a breath there. All right, so the next facet of user design is desirable. This one is another is another one that's hard to measure. You can do surveying and stuff like this, and it's another one that is harder for a Go developer to implement. But you're all already participating in desirability by being at a Go meetup. The Hired report in the US does a report on the state of software engineers every year. And they look at what software engineering is going, what the standards are in the industry, who's learning what languages are increasing in popularity and what not. And they found that Go had a 2.3 times increase in interview requests in 2021 as opposed to the previous year for Go developers. It had the highest increase. People really want Go developers right now. And the reason behind that is that Go has set itself to be extremely desirable. And a lot of that has to do with brands, aesthetics, identity, and marketing. Other languages do what Go does. Go does it better, in my opinion. Go has it goes innovations and concurrency and simplicity in that sense really helps set it apart, in my opinion. But other languages can do what Go did before. The reason why Go is doing so well, in my opinion, is it's backed by Google. It's the hot new thing. It's the new Mercedes, the new Mustang that's out on the street, and it really helped brand itself from the get-go using Google's brand as well. So desirability is everything about a design that it makes it more desirable versus a competitor. It's the shiny new paint on the house. It's the nice user interface. And it really does matter. If you have two equivalent products, people are going to go to the one that has the better aesthetic, the better brand. And it's really worth paying attention to. So that's desirability. Okay, this is my favorite facet to talk about. I love talking about accessibility. Accessibility is very broad and is often overlooked when people are designing things. Accessibility can mean a lot of things. At the basic level, to make something more accessible is to make something is to make your product be able to used by lots of different groups of people. One example of accessibility is to add language options to your product so that English speakers can use it, Hindi speakers can use it, Marathi speakers can use it, French speakers can use it, and that will really globalize your product, for example. Accessibility can also mean someone who who has some sort of disability and can't use your product because you haven't designed for that disability. And in that sense, accessibility is really important because a lot of your potential users have some sort of thing that's blocking them from using your product in a normal way. statistics for Americans, for example, is that 20% of Americans suffer from some sort of ability. That's 1 in 5 Americans who can't use a lot of things that other people can't because of their disability. And if you can design for that disability, you're increasing your customer base to that many more people. And the accessibility design has a lot more benefits as well. One great example of accessibility design is subtitles. Subtitles are originally added to movies and film and TV as a way for people who were deaf to be able to enjoy the film. They could just read the subtitles instead. But very quickly, uh, movie creators and television creators realized a lot of people just like having subtitles on. It's easy to understand if you don't understand the language that well, if you are hard of hearing but not deaf. If I use subtitles at home when I'm trying to like play the TV quiet and not have my family wake my family up at late at night. And so it made for a better customer experience overall. Another example of accessibility design is the ternary operator. This question mark ternary operator that appears in a lot of languages like C++ and Python does not exist in Go. The Go creators very intentionally left out the ternary operator from their language because they felt that it was a confusing piece of code. If you want to do what a ternary operator does, then you should be using an if-else statement. That is clear that it does the same thing, and there's no need for a programmer to do it on one line. It was a very intentional choice by the Go developers to follow their paradigm of having an easy to use language. It's an example in accessibility design. And then this bottom picture here is the accessible Xbox controller from Microsoft that allows a lot more people to play games. So accessibility is really important for all the reasons I just stated. So the last facet, we've touched on this before. It's kind of similar to being useful, but valuable. You should make a product that people want to spend money on. Otherwise, why would the user come to you? Like, why? Otherwise, why are you building the product if it's not valuable? It doesn't always have to be spending money. You should use a product that people want to use, even if you're building it for free. Um, Making something valuable isn't just at the base thing like, hey, I've made a peer-to-peer transaction app that is valuable, or hey, I've made a backend server in Go that is valuable, or one of the easiest example of something valuable, of something incredibly simple that was valuable, was a awesome search engine by Google. They built their entire company based off of one search bar. But value can also be measured in terms of cost. And I think this is the most important part of this facet. As a developer, the way we can increase value for our company and for our products is by reducing the cost. That is what we as a developer have the most control over, because the cost of developing a product is directly correlated to how long it takes us to build that product, for example. So when we're considering designing something, you should consider the cost of building that product. If a product manager, if someone comes to you and says, hey, I want to build this, and you have two options on how to build it, you should look at what option is cheaper as well. And if you can make that recommendation to your manager and say, hey, I can make it both ways, but I think we should make it this way because it's cheaper, and you end up saving the company money, that looks really good on you. Maybe you can use that to be like, hey, can I have a promotion? But because you have a direct control over the cost of a product, this is how you directly create value for your company. So that's all 7 facets. And at a glance, I talked a lot, but they are all they are all pretty simple in the end: credible, findable, usable, useful, desirable, accessible, and valuable. The hard part comes when you're trying to juggle them both together. Something that is accessible may not always at the same time be usable or useful, right? Something that something that you make easily findable may make your system less desirable. A great example of this is an airplane cockpit. An airplane cockpit has a lot of buttons, and every button has a one use, and it's very usable for someone who has a lot of experience in it. It's findable for someone who has a lot of experience in it, but in that sense, it isn't usable. Sorry. And also in that sense, it's not really desirable. It doesn't have a brand or an aesthetic or a marketing thing. And so when you're designing a product, often you're sacrificing one for the other. And a lot of the future learning comes from understanding when each facet is more important than another. Um, and that's the hard part. That's the real kicker. But in general, if you think about these facets as a whole, you'll find you'll be making better products. And when you're making better products and with better designs, you should be good. So that is my talk for today. If you're more interested in design or some of the things I've talked about today, you can read some of these books by Peter Morville, and he goes into more about it in each of these: Search Patterns, Information Architecture, Intertwingle. This blog post is where a lot of the content for this talk came from, by Peter Morville. And then something that talks about design broadly, as opposed to just design in a technical standpoint, is this book called The Design of Everyday Things. And this book is one of my favorite books on design. I highly recommend The Design of Everyday Things. They talk about doors and coffees and trains and how all these things are designed in our everyday lives, and what it would be like if they were designed poorly, like some of our software is. And it really expands your brain there. But yeah, if other than that, if anyone has any questions, please let me know, and I'll be happy to answer them. So the question asked is, who is the most priority, developer or designer? And that is a question I forgot to answer. It's a question I posed at the beginning of the talk. So developer and designer, the disconnect is fatal. That's what I said at the beginning. But the idea that someone has more priority than the other is where the disconnect starts in the first place. A designer and the best developer is someone who can understand what the designer gave him, what are the things that the designer is looking for, which I hope you know is some of these facets now. And when he understands what the designer is looking for, the developer should be able to consider his design with the development limitations of the language, such as Go, and be able to implement something that fits the design priority with the developer limitation. So in that sense, the designer has priority on what it should look like, and the developer has the actual hand to make it, and they should be working together like a hand. But yes, if that made sense, if that didn't answer your question, feel free to ask it again. Okay. Well, if you have more questions, first
We got another one.
yeah. So I mostly use Go programming personally for that's a broad Go question that maybe Dima can also answer. But personally, I use Go programming for command line interfaces, concurrent code, and backend servers is what I use Go for. And all of those things may not scream like, oh, like why do you need design for that? But you do need design for that. People are going to be using the people using your command backend services, such as your colleagues, will appreciate good design, and command line interfaces are actually a front end device.
Let me ask. Let me ask a question. How you usually deploy your code? I mean, the your CLI. How you release it?
Me?
Yeah.
Um, Most of my code deployments are, I mean, it depends on what I'm deploying. Because I'm on the partner integrations team, a lot of my code
Mhm.
deployments are just like we build a Go package, and the Go
Yeah.
package will run on a cloud node somewhere. So we deploy we store an artifactory, and then we deploy each package using our
Go binary
pipelines.
file. Yeah.
Yeah. Dima might
So
have a
we.
different way.
Uh-huh. We got another question.
Yeah, Go is a general purpose development language, but it is natively compiled, so very easy to deploy. You have one executable,
Yeah.
and
One binary file.
we use it for microservices backend. It's a very common usage in a DevOps world, DevOps tools, command line tools. But it's general purpose, so you can use it for everything really.
Yeah. That's why Docker CLI and GitHub CLI is built with Golang. So we got another question from Situ. He's asking most of the time they are on the same page to change the design.
That's an interesting question. I know I'm comfortable enough in my knowledge of design that I feel that I can change it. Most of the time, if I am changing the design of something, I am talking to the designer first. I'm saying, "Hey, designer, you wanted something to look this way, and we're on the same page about that. But because of the limitation with my language, in this case Go, because of the limitations with how Go works, sometimes I can't build it exactly how you want, but because I know what your end goal is, I can build it in this other alternative way. And if you can come to the designer with that alternate plan, it'll help things run a lot smoother in the long run. So yes, I hope you have the freedom to change it, but communicate.
Uh, Aravind is asking the Go is Golang is faster than all.
So Go is a statically typed language. It is faster than dynamically typed languages, but it also uses garbage collection mechanism. So languages without garbage collection, they generally are considered better suited for very, very high performance tasks. So for very high performance, C is usually used, or C++, like embedded, etc. But for just regular backend applications, it is considered very, very good, like on par with Java.
Okay, so
Okay,
any
seems
more
like no more
questions?
question.
We'll wait for another 2 minutes for the questions.
Yeah, sure.
So meanwhile, yeah, thank you so much, Chamod. Thank you for the opportunity, and thank you, Sushrut and Dima, for your time. It was great insights. It,
Yeah, and
mhm.
uh, and thank you very much, Chitra, Dima, and Sushrut, and JFrog for sponsoring today's meetup.
It is our pleasure to sponsor Golang Sri Lanka. We are hoping to get
Thanks.
more talks in Golang Sri Lanka soon.
Mm.
I think there are no more questions. Thank you, Golang community. It was great talking to you all. And also I hope everyone has filled the form for the raffle, as well as you can try the Artifactory free tier as well. So meet you soon. Thank you so for the opportunity. Take care. Bye bye.
Yeah, thank you for everyone who
Thank
attends today's Golang Sri Lanka meetup. Stay safe. See you in Golang Sri Lanka March meetup. Bye
Bye.
bye.